Today we'll discuss the function in C. This is the function prototype declaration. How do you know this is a prototype declaration? Because there is a semicolon should be there. If the function declared before the main, then the prototype declaration is not required. We can see it here in this example. The function is body, whole function declaration is there, so prototype is not required. So that is we call the function prototype declaration, or sometimes we call the function signature. It is just everything with the semicolon, but without body. And you see that this function call, this is the function call. This is a return type. Every function should have some return type. It may be void also, or it may be, if the return is integer or float. You have to, one has to explicitly write that is what is the return type. It is always better to have return type. At least every function should return, if everything is okay and return 0, then it should be int is a preferred choice. Here the same thing, the body of the function. Here we have a history of Unix and C. We'll discuss it some other time. The function body declaration, so we do not need the semicolon or signature it here. And remember, this actually starts executing from here and here, the function calls. So if controls goes to here, and if the stack, everything the stack is on the stack, we'll stack frame, we'll discuss, and then after this return call, it will come back to here. After it will come back to here, then it will print out, and we'll see it. This is a math library function. We should not write unnecessary functions. These are the functions already there in various libraries, and we have a joke that we should not necessarily, because the functions are already there, we should use those functions. And we should use those functions, not unnecessarily write functions like the. These are various formatting routines. This is interesting. This is the whenever we write by Nano or any program, we write it on a disk. We use any editor like Nano or any text editor. Then this linking and linking process is done by GCC. It is the whole compiler GCC or CC, and then the output file is a.out if it's not mentioned by -o option with the file name. And then whenever you run the execution file like /a.out, then the program loads it here. The program loads it here, and there will be operating system. This is the operating system part, and there may be some here the program loads, and the whole map is memory map. We discuss in our next slide. This is the slide. This is I discussed the OS kernel. This is the OS kernel. This is OS kernel. It may be Windows or Linux. Beyond that is maybe BIOS. It is ROM based BIOS. Then the OS kernel. Then the a.out. A.out file should be here. A.out. This is a read-only file, and then the global memory section should be here. Global declared and global uninitialized, and these are all like this is the BSS segment it is called. And then the heap area, it is called when the memory is allocated by malloc or calloc, or malloc or calloc, like malloc or calloc, malloc and calloc. And this is from the stack. Other end, the stack memory is used, and this is the heap area. Heap area, remember, we have to deallocate by free. Same thing here. Here it is no malloc and calloc, and yes, malloc is there. We get some memory from the heap area, and we return. And this is the pointer, and this is the return, and 200 bytes memory allocated to the malloc from the heap area. This is same way this shown. It is the reverse down. It is the program code. Here the OS. This is from the stack side. This is from the stack side, and this is from the heap side. This is of the heap, and this is from the heap area. The same picture, and here the main program. See, a.out should be there, and a.out, and if it is any parameters passing this parameter 1 or parameter 2, all should be pushed in this place. You will see it. Like here, the program is foo, the parameter main program is foo, that a.out, and these are the parameters 1, 2, 3. This is the oxy, argument count on argv. Argv is an array. Argv0 is the main program name, and these are the various parameters, and these will be loaded here. So we'll discuss in some other time. These are functions. These are functions in int. In output is int. This is a function, and we make this a main, and the function is declared here. So the function prototype has to be declared first with the semicolon, and the function body is here. And main type always in main or any other function, we should have return 0 or anything. We should have this return must be there. It indicates that it returned the correct way with the 0 output. It will help in our debugging if there any problem comes. This is when the function calls int main, it always first called int, and it goes there a10. Then whenever it asks the function to square a within the printf, there is square a. So this function's stack, the whole main stack will be pushed into this in a stack, and this value 10 will be pushed because we have initialized with the 10, so it will be pushed. And next, after the execution of this square, here, after executing this square, it will return again here. So top of the stack, automatically this will be stack frame from the mention, it will comes out. So what is the nutshell we discussed? There's a function body and a function signature, and first operating system main calls main. The main thread is main, and the main stack frame is whenever any function is called, main stack frame is pushed onto the stack. Like here main calls square, so it should be pushed. And if main calls printf, again the printf stack frame will push to the stack, and then it will be popped. At the proper ending of the function, there should be no stack frame. It will be all pushed out, and you will get the result. Thanks for the video.